This Chapter 8 video will conclude the Practical Plane Geometry chapter. We will be looking at Section 8.4 in this video, which is going to cover finding the area and perimeter of geometric figures, which will be circles in this case, and some practical problem-solving skills. So first off, just to make sure that we're on the same page about a circle and some of the definitions, the diameter, when we speak about the diameter, we're speaking about from one side through the center point of a circle and to the other edge. And so that is the diameter. I've stretched out the boundary and didn't go through the center, but you see the line there. And the radius is half of that. So from the center point to the edge. And so no matter where you go out from the center, the radius will always be half of the distance of the diameter. So that being said, we can base our some rules off of this. One of these is looking at the circumference and defining what the circumference is. And the circumference is going to be the length around the circle. So from starting at any point, going around the circle and back to the same point is going to give you the circumference of the circle. And the circumference of the circle, we use that divided by the diameter, and every single time if you take the distance around the circle and then you divide it by the diameter, you will always come out with 3.14159, and it keeps going on and on and on and on forever. It is an infinite number, and so that is a mathematical truth. So that's where pi comes from. 3.14 is the circumference divided by the diameter, and that's going to be really important as we try to look at the different formulas that we're using. And remember that for the diameter of a circle, that the diameter is always 2 times the radius, or the radius is half of the diameter, and the circumference is always pi times the diameter, or it is 2 pi r. In that case, really pi times 2r might be a better way to describe it. Now we can use these formulas to find the radius and circumference of a hole, and this hole, we're going to draw a circle, and it has a diameter, so all the way across, of 4.5. And by looking at this, by finding the radius of that, we just simply say the radius is 4.5 divided by 2, and so the radius is going to be 2.25 inches in this case. And the circumference around that circle is going to be pi times the diameter, 4.5. And we can just leave it like that, and this is actually the most truthful way to describe that circumference as 4.5 times pi. If we go ahead and put it into the calculator, which we will, we have an issue with for the calculator rounds pi down to the 10th digit, and so in this case we'll go 4.5 times, there it is, times pi, and we get a number that comes out to 4.1 inches because of our significant digits. And so 4.1 inches is the circumference, but it's not exact. So if we were wanting to get the exact number, we could leave it in 4.5 times pi. So looking at this and using this in a practical sense, if we want to try to find a hot tub that has a diameter of 5.3 inches and we want to get an extra fastening steel band added onto it, then how long would that need to be, including an extra 4 inches? And so I'm going to go ahead and let you pause the video and try this one on your own. Okay, so knowing the formula that we're looking for the circumference, right? Because we're going for, here's our hot tub, and we're going for a steel band around the hot tub, and so it's going to go all the way around, so we want the circumference of that. And so we'll go ahead and substitute in here. Circumference equals pi times the diameter, and through 5 foot 3 inches is going to be tough, so we'll go ahead and put this into 0.25 because that's a quarter of a foot. And we'll go ahead and calculate this all the way out, since we are going to need to buy some steel banding for this. And so we'll need a number that's close. It might not be quite exactly precise, but go 5.25 times pi, and that's going to give us, the circumference is about 16.49 feet. Go back and look at the question, make sure that we're answering it, and it says, oh, we need to add 4 more inches for the banding, so 20.49 feet of banding will be needed to hold the hot tub boards in place. So when we're looking at area of circles, we're looking for the space inside the circle, and so those formulas are area equals pi r squared, and then area equals pi diameter squared over 4. I'm going to tell you that this is the one that I like to use most of the time, because it's oftentimes easiest just to go ahead and divide the diameter by 2 to get the radius, and it saves you an added step. So go ahead and take a look at this problem and go ahead and pause the video. I did go ahead and include that 1 acre equals 43,560 square feet in this. So go ahead and pause the video and then try to solve this one on your own. Okay, we're back, so let's go ahead and look at how we can solve this problem. And so one of the things that's interesting is they talk about actual real world scenario where they put a central stake out, and they take a rope and they get a 40-foot radius, and so they can put a rope out, and then from there they go out 40 feet, and inside of there they counted 450 seedlings with inside that area, but we don't know what that area is, so we need to figure that out. So we'll go ahead and look at this, and we know that area equals pi r squared. And so by doing this, let's go ahead and we'll substitute area equals pi 40 squared, and so area equals pi 16 times 1600, and pull this down, get our calculator, and 1600 times pi is 5,026. So we know the area is 5,026 feet squared, and so that is the area inside of the circle. But what the question is asking, it's asking how many seeds germinated per acre. And we look at this and we say, okay, well, we have how much is an acre. So 1 acre is 43,560 square feet. And we know that we have 450 seedlings inside of 5,026 feet squared. And we can compare that to, well, we don't know how many, but X number of seedlings in 43,560 square feet. And we get to do that thing that we like to do only when we're using proportions and ratios, and that is cross multiply and divide. And so our answer says that we have 5,026 times X, and 450 times 43,560, so 19,602,000. 19,602,000. We're going to go ahead and get this X by itself. Divide 5,026, what we do to one side, we have to do to the other side, and so we'll divide by 5,026, and we get, I think it said 39, and so X equals 3,900 seedlings per acre. Okay, and that answers the question. So we're going to look at a couple other situations. One, when you're looking for the area of a circle, you can divide it up into a bunch of pie pieces. Anybody who played Trivial Pursuit can remember that. You take those into pie pieces and cut up even more pie pieces. The more pie pieces you can break up and then take and put the little wedges next to each other, you can get close to finding the area by actually building a rectangle. And so that's one way to do it, and you'll see some problems that will talk about that, and using being able to use the area of a circle formula. So area is radius of 1/2 times the circumference, and so you can just apply and substitute in the variables for that. And also another one is if you're trying to find rings. This is much like the trapezoid problem that we had on the last video, so you can go back and see how we solved for the larger ring and then solved for the smaller ring, and then you subtract out the smaller ring out of the larger ring to get the larger, or to get the ring size and from the middle, and that's what you're looking for. Okay. So if we're looking for a cross-sectional area of the wall of a pipe who has an inside diameter and has an outside diameter, then you basically turn that into a substitution problem. Whereas the inside diameter is your little r and your outside diameter is your big R. And so in this case, you just we'll just substitute. The area is pi, and our larger diameter, our outside diameter, is 5 squared minus pi times our smaller diameter, and that's 4 squared, and so that's pi times 25 minus pi times 16, and we'll go ahead and subtract those from each other, and we end up with 9 pi, which is of course the most right answer, but we can also go ahead and multiply 9 times pi, and we come up with an area of 28.27 inches squared for the missing ring section. And that concludes all the parts for this section and for this chapter.